All right, class, section 4.3, prove triangles congruent by SSS. So postulate 19, which is the side-side-side congruence postulate, also known as SSS, is if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So if we can show all three sides of both triangles are congruent with one another, we know the triangles are congruent. So if side AB is congruent with side RS, and side BC is congruent with ST, and if CA is congruent with TR, then we can say that triangle ABC is congruent to triangle RST. Make sure we're going around the triangle in the same direction. From A to B is that green line, so R to S, then B to C is blue, so S to T. So the order, remember that order matters when you're naming those triangles. So we're able to show that these triangles are congruent by side, 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 or SSS. Skip over, so the order of your notes is a bit out of order from what we're going to be going through, so skip ahead to these three examples, and we'll just skip around on the notes today. Can you prove the triangles are congruent from SSS? If yes, write the congruent statement. So first we have to show or prove, can we prove that they're congruent, yes or no? And then, if yes, write our congruent statement. So if we look at J to K, it's got the single tick mark. So M to L, that has a single tick mark. And we see K to L has 2, L to N has 2, and then L to J has 3, and N to M has 3. So yes, they have three sides that are congruent with one another. All three sides match up with the other triangle. So yes. And then we need to write a congruent statement. So you have to go start at the same corresponding vertice and go around the triangle in the same direction. So I'm going to start with J, triangle J, down to K, over to L, is congruent with triangle M, down to L, over to N. So that would be my congruent statement. Now number 2, we have JG has 1 tick mark and FH has 1 tick mark. So those two sides are congruent. FG has 2 and JH has 2. So those two sides are congruent. And then our shared line, our shared side down the middle, it's congruent with itself. So these two triangles have 3 congruent sides. So these are also proven by the SSS postulate. So this also is yes. And then we need to write the congruent statement. So our congruent statement could be FGH. It doesn't matter what letter I start with, but the order does matter after that. So if I go F up to G down to H, I would then need to start with J in my second triangle. F corresponds with J, and then if I went to G, H corresponds with G, so H would be my next letter. So J down to H and then up to G. So that would be our congruent statement for that one. Then our third example here, we could rotate the triangles if we want to. We see these are showing us the angles. This isn't talking about sides. This is showing us only angles. So we cannot prove these triangles by side, side, side. So our answer would be no. All sides are not marked congruent. So even though you've got three angles that are all congruent, that does not mean that the triangles are congruent. You have to have the sides congruent for those to be. Since all angles in a triangle must add up to 180, you could have a giant triangle that is 60, 60, 60, and a teeny tiny triangle that's 60, 60, 60. Their angles would be congruent, but their sides would not. So we need the sides to prove the triangle's congruent. Angles don't do it. All right, skip back up to this number 1 and 2, the checkpoint, to decide whether the congruent statement is true and explain our reasoning. So this one, we need to look specifically at the congruent statement before we even bother looking at the triangles. Because our congruent statement is what's most important here. It says determine whether the congruent statement is true. So we've got JKL. So if I go J to K, and then K to L, and I would also go L back to J. So my other triangle needs to match up like that. We have M to K, K up to L, following the blue line, and then L down to M. Now we can see JL and ML are both 9, so those are congruent sides. JK and MK, they're both green, so they were the corresponding sides and they're congruent. So those sides are congruent. And then we have KL, and that is the same side, it's shared. So these triangles are congruent, and the congruent statement is true. So yes, it is true. Is it true? Yes. And all vertices match up correctly. Side, side, side works. Side, side, side works. All right, look at number 2. Remember, our congruent statement is important. RST, so from R to S, there's no tick mark there. Our second one is T to V, no tick mark there. Then from S to T, we've got 2 tick marks. And that matches up with a V to W. It's got 2 tick marks. And then T back to R, it has 3 tick marks. And then W back to T has 3 tick marks. So the congruent statement is in a correct order, a proper order. From R to S, there's no tick mark, and T to V, there's no tick mark. But then the blue lines show that they're congruent, the red lines show that they're congruent. So at first glance, it looks like the congruent statement would be correct. But we only have two sets of sides that are shown congruent. We don't know that the green lines are congruent. We could have different angles between the red and blue lines that would change the length of that green line. So our answer is no, not all three sides are marked congruent. Not all three sides are marked congruent. Next, determine if the triangles below are congruent. If they are, we need to write a congruent statement. So let's look carefully at these two triangles. We see that we have two side lengths that are 5, have lengths of 5. We'll mark those in red. We have two side lengths that are 4, have a length of 4. Mark those in green. We know that this section right here is shared between the two triangles, but we have overhang. We have an overhang of 1 on each side. So there's an overhang of 1 there, overhang of 1 there. If those two numbers were different, these triangles would not be able to be congruent based off of our other sides. But because each of those little overhang bits are the same, and then the rest of the side is shared, we know that those sides are congruent. So we know that they're congruent, so then we need a congruent statement. So if I look at the triangle on the left, that would be triangle ABC. And that would be congruent to triangle, let's see, F corresponds with A. Then it would be ED, FED. So that would be my congruent statement. Maybe make a little note off to the side here that this piece has to be congruent for both triangles because of the reflexive property. So just that little piece that I marked as a blue line that little piece will be congruent because of the reflexive property. And you do need to have those overhangs congruent as well. All right, writing proofs. We're still doing proofs, so go back to the proof. On that previous page, we see our given information. Fj is congruent to Hj. We see that marked there. So that can be we need to make our 2 columns statements and reasons. Let me give myself some more room. Maybe not that much room. Okay, so we've got that as given information, so we can write that in. Fj congruent to Hj. That was given. We also see G is the midpoint of FH. So if G here is the midpoint, that means that these two sides are congruent with one another. So G is the midpoint of FH. That was also given. So because G was the midpoint of FH, and I already marked our sides congruent, now we need to show or write in our statement that those two sides are congruent. So FG is congruent to HG. FG congruent to HG, and that is definition of midpoint. Definition of a midpoint. We knew those two sides were congruent because of the midpoint. Then we need to find that third side, and we see that it's shared here. I'll mark them in blue. We can see that they're shared. So we have JG is congruent to JG, and that is the reflexive property. So now we have all three sides shown that they're congruent. We need to write our proof statement. We need to prove that triangle FGJ is congruent to triangle HGJ. And the reason for that is all three sides are congruent, side, side, side. So that's it on the 4.3 notes. Make sure you do the 4.3 homework as well.